right, Sig Figs, significant figures. We're going to write down the rules, and then we're going to do a whole mess of practice. So you have 3 rules. 1, anything non-zero is significant. So that's any digit 1 through 9. 1, 2, 3, all the way to 9. If it's non-zero, it's definitely significant. 2, sandwiched zeros. We talked about this in class. Sandwich zeros are zeros between non-zero numbers. And it doesn't have to be just one. It can be 2, 3, 4, 5, doesn't matter. So like 803. That one's sandwiched, he's significant. 8,003. They're still sandwiched, still significant. 80,003. Still sandwiched, still all significant. Then your third rule, this is the one that most of you struggle with, just terminating zeros. Those are the ending zeros. Whoops. Oh no. And you have a second part of that rule, only if there's a decimal point. So there's 2 things. It has to be at the end of the number, and there has to be a decimal point. So leading zeros, one's at the beginning, 0, 0, 0, 7. We never count those ever, whether there's a decimal or not. We don't count zeros at the beginning.
The mailman might knock because...
Okay, now that I cleaned that up a little bit, we're going to go back and forth from the review guide. 6, 0, 5. Oh, that's terrible. 0.03. Well, using rule 1, 6, 5, and 3 are all significant because they're non-zeros. And then these 2 zeros are sandwiched between these, so they are significant. So we have 5 sig figs. Back to the review guide. 20.00. Well, rule 1, non-zero, significant. Then we have a decimal, and then we have some zeros at the end. They're terminating. So rule 3, there's a decimal, and these zeros terminate the number. They end it, so they count. There's 4 sig figs. Now we're going to use the same number, but without the decimal. The exact same positions, but now there's no decimal. This only has 1 sig fig. We don't count zeros at the end if there's no decimal. So no decimal, never count a 0. There's only 1 sig fig. Now we're going to hop back up there, use the same number, but we're going to throw some zeros in the beginning. That is a terrible, terrible 0. Much better. We never count leading zeros, so get rid of them. Go back to your decimal rule. They end the number, so we have 1, 2, 3 significant zeros and 1 significant non-zero, 4 sig figs. Just like this one, because we never, ever, ever count the zeros at the beginning. Okay, here's 4 more numbers. We're going to leave this running for a few seconds so you can pause, try to solve it on your own before I show you the answers. Okay, welcome back. Now we're going to solve this. Start with this guy. We have 1 non-zero, so we count him. Then we have a 0 and a decimal point, and it ends the number, so we do count it. There's 2 sig figs here. Next, we have 2 non-zeros, and then 3 zeros. But there's no decimal point, so we don't count these zeros. So again, we have 2 sig figs. On your exam, this is the question that a lot of you got wrong. Yes, there's a decimal point right there, but we never ever count zeros at the beginning. Those are placeholder zeros. Don't count them. So even though there's a decimal, we do not count the zeros. We do count the 6 and the 3. And then rule 2, the sandwich rule, says we use the 0 in the middle. So this only has 3 sig figs. Popular answer on your test was 5 sig figs. No, it's not 5 because we don't count these first 2 zeros. And then the fourth one, we have 1, 2, 3 non-zeros. So it's going to be at least 3 sig figs. And then even though there's a decimal, we still just use our sandwich rule. They're between the 7 and the 2, which means they're sandwiched. So we count 1, 2, 3, 4, 5, 6, 7 sig figs. Okay, one more set of practice problems will work together, then we'll move on to rounding sig figs. So take a second, pause. And we're going to get going. So we're going to start here at number 1. 1, 2, 3. Row. They're at the beginning. We don't count them. Get rid of it. So we have 2, and then we have 2 zeros at the end. And there's a decimal point that I foolishly scribbled over, but there is a decimal point right there. So we do count the terminating zeros, round 3. They end the number. So here we have 4 sig figs. Next, here we only have 1 sig fig. Because again, there's a decimal right there, but there's also zeros at the beginning and none at the end. And we never, ever count the leading zeros. So the only one we're counting is the 6. 51, this one should be easy. 2 non-zeros, 2 sig figs. This next one, there's a 0 at the end, but there's no decimal point, so we only count the 5. This is 1 sig fig. Going up to here, same number, but now we do have the decimal point. So this 0 now ends the number with a decimal point. We count it. Oops. 2 sig figs. And then 3.00 times 10 to the 8th. We mentioned this in class very briefly. Counting sig figs here. Get rid of the scientific notation. And you just use the base number, 3.00. There's a decimal. And then 2 terminating zeros plus our non-zero. So rule 3 and rule 1 make us have 3 sig figs. And then the last one, we have this guy. Then we have a decimal. Then we have some zeros terminating it. So we count all of them. 4 sig figs. Okay, now rounding sig figs. Use one straight off your test. 1.990 and then parentheses 3. Now a lot of you were asking me, what does the 3 mean? It was right in your instructions. It says round to the number of sig figs, which is the value given to you in parentheses. Here's 3. That means we're rounding to 3 sig figs. First, you find your first 3 sig figs. 1, 2, 3. And then you look at the next number, regardless of significance. In this case, it's a 0. Now think way back to elementary school in your rounding rules. It's a 0. So less than 5, leave it. Greater than or equal to 5, raise it. So here we have a 0. 0 is less than 5. Leave it alone. So this 9 stays alone. 3 sig figs, 1.99. Now the other version of the test have the same one, 1.990, but it said only 2 sig figs. So find your first 2 sig figs. Look at your third one. It's a 9. 9 is greater than 5, so you round up. 2.0. You have to include the 2 because you're down to 2 sig figs.